In the vast theater of the cosmos, Earth is but a fleeting scene, while K2-18b, 124 light-years away, might be the plot twist that rewrites humanity's story. If aliens had a cosmic chat room, they'd probably be debating whether Earthlings are worth a ping. #AirHumans AFK. On June 7, 2025, in a studio nestled in Huntsville, Alabama, near NASA's Marshall Space Flight Center, screens glow with data from the James Webb Space Telescope, JWST. A signal from K2-18b pulses through the monitors, whispering of life. Discovered in 2015 by the Kepler telescope, this super-Earth, 2.6 times larger and 8.6 times heavier than our planet, orbits a red dwarf in the habitable zone, where liquid water could thrive. In 2018, Hubble spotted water vapor in its atmosphere, sparking excitement. But in 2023, JWST stole the show, detecting methane, carbon dioxide, and dimethyl sulfide, DMS, a molecule tied to Earth's algae and plankton, smelling of sweet sulfur and sea. At 117 quintillion kilometers away, finding DMS is like catching a whiff of life across the galaxy. K2-18b isn't Earth's twin. It's likely a Hyson world, oceans hundreds of kilometers deep, cloaked in a hydrogen-helium atmosphere, 80–90% of its air, with pressures 1,000 times Earth's. Temperatures might hover above Zodoteuersee thanks to hydrogen's greenhouse effect keeping water liquid. Life here wouldn't need oxygen. Picture microbes breathing hydrogen or glowing jellyfish-like creatures drifting in the deep, their bioluminescent membranes shielding them from crushing pressure. A 1950s experiment showed lightning striking hydrogen, methane, and water vapor can forge amino acids, life's building blocks. If it happened on Earth, why not K2-18b? Yet the DM signal is only 99.7% certain, 3 sigma, not the gold standard 5 sigma, 99.99% on Palfinet. The absence of ethane, a typical DMS byproduct, raises doubts. Could DMS stem from ultraviolet light reacting with methane and hydrogen sulfide, as seen in comets? With DMS levels 1,000 times Earth's, such a reaction seems unlikely, but the question lingers. K2-18b is more than data points. It's a mirror reflecting humanity's place in the universe. If life exists there, would it unite a fractured species or deepen our divisions? Perhaps from those distant oceans, unseen eyes watch, wondering if Earth's chaos is a civilization or a cosmic blooper reel. In Huntsville, where rocket engines once roared, K2-18b ignites a new fire. The possibility that we're not alone, and the chance to redefine who we are among the stars. In the year 2165, a spacecraft named Aurora glides through the void, its quantum propulsion system perfected in the 2100s, carrying a crew toward K2-18b. The mission: verify the DMS signal and seek life. Inside the control room, screens project a 3D model of K2-18b, a shimmering blue orb veiled in hydrogen clouds, orbiting its red dwarf star. The crew, a blend of engineers, biologists, and astrophysicists, buzzes with anticipation. One points to a spectral chart. Its peaks at 1,400 nanometers, water vapor, 5,000 nanometers, methane, and 12,000 nanometers, DMS, glowing like cosmic fingerprints. The DMS is real, a biologist says, but no ethane. That's the puzzle. An engineer chuckles. Maybe we're chasing a galactic storm, not life? The astrophysicist counters. With DMS this strong, it's more than chemistry. We're about to find something big. As Aurora nears K2-18b, the planet fills the viewport, its oceans glinting under the red dwarf's dim glow. The crew prepares a shuttle for descent, targeting the region with the strongest DMS signal. Pressure's 1,000 times Earth's, the engineer warns. If it's acid, we're toast. The biologist grins. No acid. Data suggests water, maybe teeming with microbes. The shuttle dives through hydrogen clouds, the hull groaning under immense pressure, and lands on an ocean that sparkles with bioluminescent flickers. Suited in pressure-resistant gear, the crew steps out, their boots sinking into a liquid world. The biologist's scanner beeps frantically. "Got it!" she exclaims. "Glowing microbes producing DMS, just like Earth's algae." In the distance, a massive shape drifts, jellyfish-like, its translucent fins pulsing green and purple as if breathing hydrogen. The engineer runs a scan. Pressure's stable, but still no ethane. If these critters make DMs, where's the byproduct? The biologist kneels, collecting a sample from the water. Maybe their biology skips ethane. Or our models are off. The AI on board, a digital archive of 21st century science, chimes in. Probability of biological DMs is 92%. Sample the large creature for confirmation. The shuttle's robotic arm extends, gently scraping a glowing fin. The sample shimmers, as if alive with countless microbes, ready for a close-up in a cosmic documentary. Back on Aurora, the lab hums with activity. Under an electron microscope, the sample reveals cells without nuclei packed with hydrogen and sulfur sacs. They metabolize hydrogen, the biologist murmurs, like Earth's ancient microbes, but more advanced. The engineer smirks. Cool, but I was hoping for aliens with spaceships. The astrophysicist laughs. Give them 1,000,000 years. These could be their ancestors. A simulation flickers on screen. K2-18b's oceans, thousands of years hence, dotted with floating cities glowing like coral reefs. Jellyfish-like beings, now intelligent, weave chemical clouds, their light patterns a language of sulfur and luminescence. If they have a civilization, the AI notes, it's not like ours. Hydrogen clouds block the stars, so their science might stem from ocean cycles, not astronomy. The crew gathers around a viewport, K2-18b's radiance filling their eyes. Earth has oxygen, clear skies, radio signals, the astrophysicist muses. K2-18b has hydrogen, thick clouds, maybe plasma waves. We see stars. They see oceans. The engineer adds, if they're tidally locked, one side's always lit, the other dark forever. Their lives would revolve around that divide, not our 24-hour days. A dynamic comparison plays. Earth's blue skies and radio towers versus K2-18b's murky clouds and plasma pulses. The contrast is stark, yet both worlds share a spark of curiosity. What if K2-18b hosts a civilization? The crew debates in the mess hall, like scriptwriters crafting a sci-fi epic. They'd build cities on the ocean's surface, the biologist suggests, powered by lightning storms, plasma waves for communication, since radio can't pierce their clouds. The engineer frowns. Sounds great, but what if they're hostile? We're just a speck out here. The astrophysicist leans back. Or they're curious like us. Maybe they've been sending signals, but we're too primitive to hear. The AI projects data from 2023. Low ammonia levels, absorbed by the ocean, confirm the Hycean model. But the missing ethane, it adds, suggests either unique biology or an incomplete spectral model. The crew decides to send a test signal, a plasma wave sequence, coded to mimic K2-18b's 33-day orbital cycle. The signal pulses from Aurora, vanishing into the hydrogen haze. Silence follows, the vast distance to Earth sinking in, like waiting for a viewer to hit like across centuries. The AI breaks the quiet. Chance of a reply within 100 years is 0.001%. A response would rewrite humanity's script. The crew exchanges glances, the weight of their mission palpable. The next day, the shuttle returns to the ocean, and a scanner detects a rhythmic light pattern synced to the planet's 33-day cycle. The biologist gasps, "This isn't random, it's structured!" The engineer checks the data, voice trembling. Plasma waves, but complex, like a signal. Someone's broadcasting. The AI analyzes. The pattern uses DMS-like chemicals, modulated by frequency. It could be a language of light and sulfur. Probability of a civilization, 87%. The crew stares, hearts pounding, as if they've just premiered a blockbuster to the galaxy. Weeks pass, decoding the signal like editing a cosmic vlog. Each light pulse tells a tale. Beings in K2-18b's oceans evolved from glowing microbes to sentient entities, crafting coral-like cities. They sense the universe through ocean vibrations, blind to the stars behind their hydrogen veil. Their signal asks, "Who are you?" The crew sends a reply, encoding Earth's oceans, starry skies, and a message. "We are friends." They know no answer will come in their lifetimes, 248 years for a round-trip signal, but the act of reaching out feels like a triumph. Doubt creeps in, as it always does in science. What if DMs isn't from life? the engineer asks. What if the signal's just a natural glitch like plasma from storms? The biologist shakes her head. The pattern's too intricate. The AI cites 2023 data. DMS could arise from UV light reacting with methane and hydrogen sulfide. Probability of non-biological origin, 8%. Confirmation requires 5 sigma certainty. The crew collects more samples from the jellyfish-like creatures, revealing a microbial network producing DMS, yet still no ethane. Their biology might differ, the biologist muses, or our models need tweaking. Science, as ever, trades one answer for 10 new questions. As Aurora prepares to leave K2-18b, the crew gazes at the planet, its oceans fading into the cosmic dark. A simulation shows Earth and K2-18b, two worlds linked by a thread of wonder. The signal, whether from life or nature, changes everything. If a civilization watches from those depths, what do they see in humanity? A species torn by conflict, or one reaching for the stars? K2-18b is a reminder that the universe is not just a stage but a chance to rewrite the script of who we are. Humanity may be smaller than stardust, but its curiosity burns brighter than any sun. The mission's data, samples, scans, and the mysterious signal will reach Earth, sparking debates that echo through centuries. DMS, whether from microbes or chemistry, marks a leap in the search for life. JWST and future telescopes will hunt for ethane, sulfur compounds, and new biosignatures, each step a frame in humanity's cosmic montage. K2-18b's oceans, glowing with possibility, challenge the species to look beyond its divisions and embrace the unknown. Back in the studio of the mind, where What If Universe might one day air this tale, a call to action rings out. What would life on K2-18b be? Microbes, glowing jellyfish, or a civilization? The question is posed to an audience across time, urging them to share their ideas, to like if the cosmos captivates them, to subscribe for the next chapter. A poll flickers. Life on K2-18b is A. Microbes, B. Aquatic, C. Civilization. The universe waits, its stars twinkling like upvotes, for humanity to add its voice to the galactic stream.